average and harmonic average. And we have an input file and we have to create an output file. Okay, so in my code, the first step for me would be to declare the variables. And what I have here is I wanted to have a file pointer for input. Let's call it file ptrn, and I'll have another file pointer for output. Let's call it file ptr out. The next step would be to open the files. Open the files. So here I would open samples in .txt for reading and open some samples out.txt for writing. Okay. And then I need to continue the code. In declaring variables, I also need to have float or double array that holds my the array that I'm reading from the file. Let's call it float x, for example. But I don't know the size, and I said if we don't know the size, so we better come here and create a compiler variable, a constant, all uppercase max, and set it to 100. I know that this txt file doesn't have more than 100 variables in it, so this is a workaround. I'll use this to create my variable. And then, so actually let's comment everything. This is the array. And I'll create an integer n. And this integer n is actually the size of the array. So I have an integer that helps me keeps track of the actual size of the array. And I'm going to calculate average arithmetic that would not be an integer. Float if we're doing single precision, double if you're doing double precision, equal to 0.0 f. And be careful when you're defining double that f is necessary, because if you don't do it, compiler will get it as double and then cast it to float. And the next thing is geometric average. And the same thing for harmonic, which should be easy for you to do. Okay, so after opening my files, the next thing I wanted to do is the next step is to read the data into the array. And how I'm going to do that is just using while loop and fscan f function. That should be easy. You've done that already. And this way you can also count n. N would be the size of the array, and you can calculate how many numbers that you're reading while you're reading the array, reading the input file. Your next step would be to calculate the averages. And to calculate averages, it's just the equation provided in the question. You just need to code that, and that's math. That's easy. And whenever there's a summation, you can easily do it with a for loop. And the last step is to output the results. So just some fprintf functions. And last but not the least, close all the files you have opened. Okay, so these are the steps that you need to follow to complete question number 1. Any questions? Okay, cool. So question number 2 is a trick question. It's just asking the same thing. Just do what you did in the question 1 and write a function averages that calculates all the averages. So that's actually a great way to write functions. This is what we do in actual day-to-day programming. You write something and then you see, okay, I'm going to use this instructions a couple of times, so why not make it a function to be more efficient? To do that, so the function I wanted to create here is void and averages. I'm going to take the address of the array. So I would say array ptr and integer size of the array size. And I'm going to take another float number, which is the pointer to the average arithmetic, and another float pointer to average geometric, and float to pointer, and this should be ptr, average harmonic. So just copy the function definition and paste it here. Okay, great. Now, in the body of the function, what I need to do is basically calculate the averages. So what I did in this step of my code, I can move it to the function and do it in the function. So we can have an iterator I, for example, and then I can either initialize them as 0 in the main function or initialize them as 0 here. I'd rather do it in the function. So instead of doing this, even if I have to do it in main function, I'd rather do it in the function as well, because you never know who's going to use your function. So what I would do here is dereference the pointer to the arithmetic average and set it's equal to 0.0 float number, and do the same thing for all three of them. And then you need a for loop to calculate the sum and then averages. And then after the for loop, let's break it to 2. So you need the for loop to calculate the summations. Then you can calculate the averages. Okay, should be fairly easy. Then we don't need this step here. And the whole count. What I would do here now, I would come in the main function, call my average function. The average function takes the array, which is x. It takes an array pointer, and the name of the array is actually the array pointer, is pointing to the first argument or the first element in the array, which is the first index in the array. And then the size of the array, which is n. And then a pointer to the 3 variables we create for saving the averages. So I need to send the address of average arithmetic, the address to average geometric, and average to the harmonic. Address to the harmonic average. Okay, and this is how I'm going to call my function here to calculate the averages. Any questions? Okay, so let's go over question 3. Write a program max min. I'm not going to read the whole question, but the question is about reading a file, marks in, and having an output marks out. And what I wanted to do is to have functions, different functions, a function read value. So let me read actually this part. So open 2 files, samples in .txt and I was talking about the question 4, sorry. So this is in this question, we open 2 files, samples in .txt and max min out.txt. And the next step is to call the function read value, which reads the value from the samples in .txt into the array x, and return the value of n, which is the number of values in the file that you read, the size of the array. And then call the function range, which computes the maximum and minimum values found in the array. Cool. So this function calculates both maximum and minimum. And write the maximum and minimum values to a file maxmin.out. And the output should look like there are 80 values in the array, and the maximum is this and the minimum is that. Okay, what I would do for this, let me delete here. Okay, so inside my main function, I'm going to first declare my variables. And step 1. And I have a file star file pointer in. And another file pointer for printing the output. I need a array to, let's call this value. The question said X, but it doesn't matter. I don't care what the name of the variables you choose. I rather you have the name that is readable, but it's your choice. So the array, and then integer size of the array, and then double maximum the maximum and double minimum. So you see, the good point is when I name the variables the way that I can read them, I don't need even to leave the comment, because this maximum minimum, it's just the maximum minimum. You don't need to leave comment, then your code would be much easier to read. Okay. The next step 2, open the files. So file pointer in f open, and the name of the file. The name of the first file that we wanted to open is samples in.txt, and I'm going to open this for read mode because I want to read the file. And then file pointer out and f open samples out.txt. This one I'm going to open it in the write mode. Okay, cool. So based on what question is asking, the next step 3, is to read the data into the array. And I have to do it in a function. So I rather have a function that read value. Let's make functions uppercase so we don't miss them with variables. Read values. And the function takes the file pointer and read the value from the file. So file pointer in, because we are going to read the values. And then I need to provide the address to the array as well. So while we are reading the function, while we're reading the array, I want the function to put it inside the array. So I have to specify the address to the array, and the address to the array is just the name of the array. This function can also have a return value, and that return value could be the size of the array. Oh, made its size reduced then here. Okay, so let's go ahead and implement this function. So this function clearly is an integer function. It returns an integer. The function name is read values. And this function takes a file pointer. Let's say file ptr. And the next is the address of an array. So let's say double star ptr array. So this way I would know it's an array in the function. So let's implement the function. Here, in the body of the function, I wanted to count how many numbers that I'm reading. So I'll create a variable count and set it to 0 because it's going to be used in a loop to see how many values I'm reading. And then I'm going to create a while loop, as we do always, and use the function fscanf to just provide the file pointer. Oops. File ptr. And then the next thing is I want you to read the formatted LF for me. And please place it into the memory address of ptr array. And please do this until you reach end of the file. And in the body, I need to increment the count. But if I do this loop, it will always, when it reads a value, it will write it to the first memory address. You remember in the previous session, it will write it to the first element in the array, but I don't want that happen. I want the memory to be shifted each time. So I'll add counter here. So count, not counter. I'll add count here. So if count is 0, we're adding to the first element. If count is 1, we're adding to the second element. If count is 2, we're adding to the third element. And then count would do its job and hold the size of the array. The point is, the array starts from 0. So when I'm writing to the index 100 and the index 99, for example, the size of the array is 100. Count would be 99, and pointer plus 99 points to the hundredths element in the array. I'll write this double that I'm reading from the file to the hundredths element in the array, and then I'll increment count then count would not be 99, would be 100, and we'll exit the for loop because that's the end of the file. And now count is the size. Then I can easily return count, which is the size of the array. So let me clean the code. And we don't need a semicolon here. Okay, cool. One thing that I have to emphasize here, guys, is you shouldn't go ahead and write the whole program and then see if your program is working or not. You should always check your code while you're writing it to see. Imagine I write another function and I find out that, okay, my first function wasn't working. Now it would be disaster to debug the code. If I debug this code right now and see the size and file pointer and value are correct and the value is being modified correctly in the function, then everything is fine. Now I can move to the next step of the code. But one thing we need to do is we need to have the input file. So what I would do here, I'll go to the Solution Explorer, under Source, click Add New Item, and under the name I will say samples in.txt. Okay. I'll put it here. And let me copy the content of the file that I provided to you here. Let me actually hide this. Okay. So this is the file samples in. I'll save the file. Okay, now my code should be able to read the file. It's a good practice always to have the guard that if the file doesn't exist, it will prompt you on, and it will then destroy your code. So always add that, but right now I don't have it. Okay, the code compiles without any error, but now let's debug it to see. Oh, I forgot to put any breaking point here. I'll put a breaking point at the first line because I wanted to check everything in the code. F5. I don't need the memory module. And I want to see the local a bit bigger. Okay, cool. So I'm at line 18. Okay, so you see that the file pointer in now does have a value, does have a placeholder. It means that we were successful in reading the file. The next file pointer out, it also has a value. It means that we were able to create the file. Okay, so in line 22, I have this function. Let me step into the function, F11, or click on this button. Now in the function, the local variables are count, file pointer, and PTR array. PTR array, don't forget, that points to the first element in the array. It's not an array. It's just point to the first element of the array, which is basically an array. Okay. What array is actually what array is a pointer to the first element in a block of memory. Okay, so if I step over, count would be initialized as 0. Now, the while loop. In the while loop, I'm reading the file using fscanf, and then read the first argument, place it in the first element of the array, and then continue. So let's see what will happen in the first loop. So fscanf return 1 means successful. And you see that the PTR array 14.73, and as you can see, 14.73 is the first number in the file. And if I step over, okay. So you see, as I'm stepping over, all the elements in the array are, the code is reading the elements in the array, but let me actually open the memory module. Let me go back to the main function. So step out, we're in the main function. Let me open the array. If I say value, which is the address of the array, it will open. Yep. So as you can see, it's not, it's initialized. The array is successfully initialized. It obviously doesn't show all the, it's probably 80 lines. It's exactly 80 lines. It wouldn't show all of them, but you get the point. So it will continue incrementing the pointer, and then it will initialize all the elements in the array. The other way to make sure that the code is working is just to put a printf statement. Let's actually do that. Let me exit debugging mode. Printf, I wanted to print on the screen that %lf with 2 decimal points, and it should be value I, and then let's put this into a for loop, sorry, and I start from 0. This is a clear for loop for looping through an array, and we're going to use this a lot. Let's put the /n so everything within. And I need a semicolon here, Control F5. Oh, you guys don't see that screen. Let me ship it this one. Yeah. Okay, cool. So you see that the value 14.74, and then till the atheist number, which is 18.82, and the last number is here, 18.82. All of them are being read in the function, so my printf function worked, and now I'm sure that the size and the array is working. Now I can go to the next step of the question. So in the next step, it's asking me to create a function called range. This function should take the array, obviously the address of the array, which is just the name of the array, and then the size of the array. And then I wanted to calculate maximum and minimum, so I'll provide the address of these, because it's basically the return value of the functions. If I just send the maximum and minimum, it will be passed by value. When I do pass by value, a copy of maximum and minimum will be sent to the function range. I want the exact maximum and minimum I have in the main function to send to the range function, so I would use the address and pass the minimum. Cool, semicolon. So now I have to declare this function. Let me clear this breaking point here. And range function. So what is the range function? I would ask myself, like, do I want the range function to return anything? No, I don't want it. So I set it as void. And then what else? And what are the input arguments of this function? The input arguments will be integer, not integer. It's a double array. So double star ptr and double, not double. The next thing is the size of the array, which is an integer, and I'm just passing it by value. So just integer array size. And let's actually name that ptr array so we don't miss it. And then what I need is a double pointer, because we want to take the address to maximum, max, and double pointer min. The only reason I changed the names, I just wanted you guys to see that the names doesn't matter. The name in the function, for example, you use printf function a lot, but you don't know the person who developed printf function, what are the variables they use. So the variable names in the function doesn't have to be the same as the variable names in your main function. Okay. Let's implement the function here. And in this function, let's create an incrementer I. And what I want to do is maximum and minimum has to have an initial value. Imagine there was only one number in this file. That would be both the minimum and the maximum. So let's actually do that. Initialize them. And these are pointers. Let's actually name them pointer maximum and pointer minimum. Okay, we decided to initialize them. So I dereference it again. So I have access to the value of this variable, pointer maximum. And I want to initialize it to the first element in the array, because if the array has only one element, that element is both the maximum and the minimum. So ptr, I can do it in two different ways. Just say ptr, just dereference the ptr array because it's pointing to the first element in the array, or use bracket indices. There's no difference between these two. So let me actually write that, comment to the same code. It's not identical, it's performance-wise. The second one is better, but in case of the programs we write in this course, it doesn't matter. And then I need the for loop. In the for loop, I'll create, I don't need to create my iterator outside the loop. Let's create it inside the loop because I don't want to do anything with I after the loop. So I starts from, let's actually put it 0 first, but 0 is wrong. I'll tell you why. And then while I is less than the array size, I plus plus. So I'll have an if condition here. So now I'm incrementing I from 0 to the array size. I'm going from the first element to the 80th element in the array. So each element, imagine there are only two elements in this array. There are two numbers, two values in this samples in file. So if the one that I'm just reading, the second one, so this one is, now I wanted to point to the second element in the array. That's why I want to start from 1 rather than 0. Okay. So if the second element, this is the second element. If the second element is bigger than the value of the PTR max, then what I want to do. So what I want to do here is I want to set that one. That's clearly the maximum then, because, so imagine in this case, it was 14 and 78. It's not 78 in this case, but just bear with me as an example. It was 14 and 78. 78 is clearly bigger than 14, so we will choose that one as the maximum. But if it's not, in this case, for example, it's 14 and 7.8. 7.8 is clearly less than 14, so this if condition would be false. And it's not X, we have PTR array, sorry. Cool. It's good that Visual Studio errors this to us, so we don't need to debug it later. And I don't have I, but I used I to initialize this. So I want it to be the first element, so I'll just manually put it 0. And the other thing is, if it was bigger, I wanted to put it as the maximum. So PTR maximum would be this, PTR array I. And also I wanted to compare it with the minimum. So if the PTR array I, so the index of the array, the element that I'm looking at right now, for example, the second element in this case, if we are in the first loop of the for loop, if the second element is less than the PTR minimum, the value of PTR minimum, because PTR minimum is an address, the value that PTR minimum is pointing to, then I wanted to modify the minimum, because that's clearly not the minimum anymore. So PTR min equals to the pointer array I. We had experience writing min and max functions, so this is clearly that. But you see that I'm here in line 57, I'm using PTR min for on the first loop, but I had never specified what is PTR min, and I have to initialize it first. So the same way that I initialized maximum, I have to initialize minimum as well. Otherwise, the code wouldn't work. So if we have only one element, which is the index 0, both maximum and minimum will be that index 0. And this will take care of that. And then if we have more than one, this for loop, the job of this for loop is to go ahead and check all the other elements in the array against the maximum and minimum. Okay, and this is the function. But I got a good question here. Would using count plus plus, PTR array plus plus work the same as PTR array plus count? It's exactly the same thing. Yes, instead of doing this, I could have kept it PTR array and then increment PTR array here. So by incrementing PTR array, incrementing the memory address each time. So The first time I read one, I'll increment the memory address, then increment the memory address. So exactly identical, same code. Exactly, I can do that here as well. Instead of just using the index I could have, the same way I told you here, I could have just say pointer array plus I. But here I should be careful that when I wanted to dereferencing it and what I want to dereference, I definitely want the memory to move, then being dereferenced. So this is what I want. And I can paste it instead of all 4 of them. Cool. Okay, let's watch our minimum and maximum and see if the code is working. Debug the code. We don't need to see that window. Okay. Okay, I'll step over this function here. Okay, so you see the min and max are weird numbers, means that we haven't initialized them. And if I step into the function range that we just created, so now I'm initializing them with the first value. So I expect after line 47, PTR max points to 14.7. Cool. PTR max is pointing to the first. And then PTR min should point to the same thing as well. Cool. And now I'm in the for loop. In the for loop, you see that we have the variable I, and that will be initialized as 1. So now in the if condition, I'm looking at the first element and compare it to maximum. Is that, so then the second number is 7.8. Is 7.8 bigger than 14.7? No, it's not. So if I step over that if condition, because it's false, the condition, the if statement, the statement inside the body of the if statement, wouldn't be executed. And then the next if, but that one is true because 7.8 is less than 14.7, which is the previous minimum, and we need to update the minimum. Then it's true. We go to the body of the if structure, and then if I step over, you would see that this PTR minimum would change from 14.7 to 7.8. Cool. And you can continue the code to see that both the maximum and minimum are being executed. Let me step out of the loop and step out of the function. How can I completely? Okay, let me continue. I'll put a breaking point after on the return 0. And let's debug it to see if everything is working. Okay, now maximum is 63.6 and minimum is 4.8. It means that the code is working the way it should be. Also stop debugging, and then you can add your printf statements here. fprintf, and then don't forget to close the files. Okay, cool. Any questions? So question 4 A set of student IDs and marks are read from a file using the function readMarks. The user is allowed to update the marks using the function changeMark, and the marks are printed to an output file using the function writeMarks. So this is a good question, because a sophisticated system like Brightspace you see, someday they were just these simple lines of code, and they evolved years after years to become this system. And to learn the basics, if you write this code, if you write the code for this question, you will learn the basics. There are some points about this question that I wanted to point out to you guys. Let me clear my Visual Studio here. So step one, always declare your variables. Let me start my, so file pointer, file ptr in, and file ptr out, because we wanted to have an output file as well. And then I'll have an integer number. That integer number is the actual number of marks. I forgot the semicolon. I'll create an array, integer array ID. And the size, let's put it at max. So this is an array that stores the student's ID. And the next would be a double or a float, doesn't matter in this case. Mark. And again, I'll set the size as maximum. Array. The array that stores the marks. And I need another double, which is the new mark that we want to get from the user and update the marks. So updated marks. And integer found. What is this integer found is I wanted to have an indicator, a flag, indicates that ID number was found. So I want to have, it's like a condition. It's like either true or false. Did I find the ID that the user is inputting or not? So first thing you should need to do in this question is to read the IDs and marks into the arrays we just created. I definitely need a function to do that. The function would be an integer and return the number. And the function would be read marks. We'll get the file pointer input. And then we'll get the index, the first index of the array ID and the first index of the array mark. Okay, so this function will read these two for me. I'll leave you guys to create this function because it's just similar to the one we just did. And then update the marks. Okay, here I wanted to have an infinite loop. The reason I want to have an infinite loop because I wanted to break it into the loop, inside the loop. So I'm going to prompt the user enter the student ID and 0 to quit. So basically I'm creating a menu. If a student puts 0, it means I want to quit. And the new mark. Okay. Now what I'm going to scan is from the user, I'm going to scan a %d, which is the ID, an integer, and a %lf, which is a double, which means the number. So I'm going to say this is the ID number, and it has to be the address. So I need another variable here. Let's create integer. It happens a lot. During writing your code, you see that you need another variable. You just go up and declare your variables. You can just go ahead and declare a variable here, but be careful that we are in the scope of the while loop. Do we want to do that or not? It's good that if you know what you're doing, it's fine. If you don't know what you're doing, just go ahead and declare it in the top of your code. And then the next thing would be mark, and I wanted to place it into the new mark array that we just created. Okay, cool. The first thing I want to do is to complete my menu. If user input 0 as the ID number, so if ID number is 0, break the code. Break the loop, sorry. So this is one way to do it. This is the way that I rather doing it. But another way would be just to initialize ID number as 1, for example. And then I'll move this condition here. And I can get rid of this if statement. So while ID number is not 0, continue doing this loop. It's a bit cleaner, but it's just a matter of your choice. The performance wise, this one is better. And I can't just say that performance wise this one is better. We have to actually test it to see which one performs faster, but as if the result is our concern, they're identical. But be careful, if I'm using it here, it means that I have to initialize it. So while ID number is not 0, continue working the code. Let me go back to the one that I rather use. And then I want to create a function, change mark. This change mark function takes the size of the array, which is number, takes the pointer to the array IDs, pointer to the array mark, and will take post the new ID number and the new mark. Semicolon. So this function takes the new mark and the ID number, search in the array, and if the ID was found in the array ID, it will change, or I can say update the mark of the student and return 1 as the found is true. If we couldn't find the ID number in the array in the array ID, no update will be done because we don't know what to change, and found should return 0. Function, sorry. Or found should be 0, or function should return 0. This way, I can have a check here. Just use an if statement that prompt the user to prompt the user that the student is not in the list. Okay. So this is a simple way to create a menu system. So user enters 0 to exit, or if they enter something that is not available in your array, we just prompt them that the user doesn't exist, and then continue your while loop asking them what is the next student. Okay, cool. Any questions?